All right, hello guys again. So this is second video of our sheep heart dissection. This one will not be nearly as long because I don't actually have to make any cuts because I've already cut this one. So this is the healthier of the two sheep hearts, okay? And I've already made the main cut through it. And then you notice I've got these straws that are actually going to be running through some of the more important vessels. So this straw over here is going to be running through a vessel called the superior vena cava. Okay, and that's going to bring all the blood from like your head and your neck and your chest and your upper body to the heart. There's also another vein called the inferior vena cava. That vein is actually going to connect into the pericardium and then empty into this tube right here. So since there's no pericardium on these hearts anymore, they've removed that when they preserved them. That particular vessel is not exposed at this time. Okay, so that's going to go and bring deoxygenated blood from your body, and it's going to put it in the deoxygenated side. If you remember, right side. Okay, so this one, okay, looks a little cleaner. All right, so we've got the right side of the heart once again on the left-hand side because we're looking at it as if it were in the chest. We've got our septum, and then we've got the left hand ventricle, or the left side, which has this big open left ventricle. So if you notice, like, look at how big this left ventricle is and how spaced out it is. And remember Fatty McFatterson's left ventricle, okay? Teeny tiny. Okay, sorry, Fatty McFatterson. Just named a sheep, guys. So this sheep, much healthier, still has like the strong muscle that you need, okay, but that left ventricle has that much more room for the heart to pump blood more efficiently. Okay, this like spiderwebby stuff. They bring it up close. There's your bicuspid valve, right where my thumb is. Okay, and so you can see all those little strings. Those strings, those are the chordae tendineae. Okay, and I had to cut through those, and it's very much like a tendon material. Okay, almost like really stiff guitar strings. Okay, is what they remind me of. So those are your chordae tendineae, which help to hold the bicuspid valve in place. Okay. Now the other straw, if it hadn't fallen out, okay, good. It's kind of a bear to get in there. Good. Okay, there it is, focused. Okay. This straw is going to be in the pulmonary veins. Okay, so this is going to bring blood back from the lungs, which are just next door, and it's going to bring back blood into this vessel to empty it into the left side of the heart. Okay. All right, so I've set up a concoction. I don't normally do this in class, so you guys are getting a special fun time. So I've got, this is just water. It's not actual blood. Don't worry. Hopefully you know that blood is not that color nor that color. All right, so we've got red blood, okay, which is oxygenated, okay, and then we've got this blue water here. Now blood is never ever 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 blue, much to many people's belief or disbelief because they always believe everything they see on Facebook and whatever else, okay, but deoxygenated blood is actually still red, okay, which if you watch any like laparoscopic surgeries online, maybe I'm not the only weird one who does that. No matter where your blood is in the body and where it is in that whole system, it's still going to be red. Okay, the blood only looks blue because your skin acts like a filter. So when you see a vein, okay, it's almost like putting on those old school 3D glasses with the red and the blue filters on them, which I haven't seen in years. But it's kind of doing that same thing. So the yellowish, palish white skin, okay, over top of that red, okay, filters out a lot of the different colors, giving your veins a greenish blue appearance. However, if you were to cut into that vein right there, it would be red blood. Um, Oxygenated blood is slightly brighter red than your deoxygenated blood, which has a little more of like a burgundy tint to it. Now, sidetrack, sorry. The real reason why I'm using blue is because in a lot of the like textbook diagrams and models and diagrams you see on my PowerPoint, the deoxygenated side is always blue. Not meaning that the blood is blue, it's just that they were looking for a way to symbolize that the blood is deoxygenated in that part of the heart. And they use the opposite color of red, which is blue. Okay, so blood's not blue. Sorry to burst your bubble. Ruining dreams. That's what I do. So with this deoxygenated blood, okay, if everything works out as it should, okay, when I inject this blue blood, which isn't really blue, when I inject this deoxygenated blood into the superior vena cava, we should see it coming out of the right side of the heart. All right, I'm going to grab some paper towels because even though I have this tray, guaranteed to make a mess, and I don't really want my kitchen to be blue. No offense, kitchen. All right, so we're going to go ahead and inject some of that in there. Okay. Now, you can see it's spreading out onto that paper towel, and hopefully when we open up our heart, we will see, aha, look at all that blue dye. Okay, so that is going from that straw in the superior vena cava vessel into the right atrium, and you saw it because, well, the heart's cut in half, spilling out of the right ventricle as it passed through that, well, it passed through the tricuspid valve into that right ventricle. Okay. Now the blood from there is going to go back up into the heart, and it's going to go into the pulmonary vein, or excuse me, pulmonary artery. That pulmonary artery is going to have a pulmonary valve. That's the word I was looking for before. Okay, we've got aorta. Here we go. All right. So if we take a look, sometimes this pulmonary artery is so sneaky to find. It's a lot easier when like things are alive. Okay. All right. Sorry about that. Sometimes you just got to poke around a little bit until you can find it. There it is. Okay, so this dissection probe, okay, I have pushed through that pulmonary artery. Okay, come on, focus. Okay, so I've pushed through that pulmonary artery, and you know you're in the pulmonary artery because look, it's on that right-hand side on the right ventricle again. Okay, now remember I've cut it in half. This is why I'm showing you like the top half. So the blood's going to come from that right ventricle, out of the right ventricle, to the pulmonary artery. This pulmonary artery is going to branch off in either direction and take your blood, take your deoxygenated blood, okay, which would still be blue technically, and then go to the lungs. The lungs are going to be right next door. And what happens with the lungs is the blood is passed through a bunch of capillaries. And those capillaries is where we're going to lose that carbon dioxide from the rest of our body and gain the oxygen. So all of a sudden, we're no longer going to have deoxygenated blood. We're going to have oxygenated blood. Okay. Sorry, I had to clean up my syringe in the middle of that because I only have one. So instead of going through the superior vena cava, when it comes back from the lungs, it's going to go through these pulmonary veins. And the pulmonary veins will take that blood into the left side of the heart. Okay. Now what happened is I had to hold the heart upright because see this little hole right here? That's actually the other pulmonary vein. So there's one for the left-hand side, one for the right-hand side because you have a right and left lung. All right, so we're gonna pour some blood in there, nice and oxygenated. And when we open this heart back up, yep, remember, not real blood, just dye, okay, food coloring that I found in my kitchen, okay. So what happened is this pulmonary vein leads right into, I've used all my pokey things, leads right into the left atrium. Sorry if I said right before, it should be left atrium, which passed the blood through the bicuspid valve into the left ventricle. Okay. Now what happens is then the left ventricle is going to contract these supramuscular walls. It's going to go straight up this direction. Okay. And you can almost see it right here in this valve, in this vessel is going to be your aortic valve. Excuse me. Okay. And this little like slit like hole right here. Okay, and it's going to go up and out of the aorta. Okay, so we actually have 4 vessels right here. If my dock camera would actually focus. Here we go. All right, so we have our superior vena cava, bringing deoxygenated blood in. We have our pulmonary vein. No, pulmonary arteries. Oh, no. Sorry, I shouldn't be recording at like 10 o'clock at night. We have our superior vena cava. Then we have our much bigger pulmonary artery, right, which is where it came from the right side, takes it to the lungs. Hey, lungs, give me oxygen. Then the blood is going to come back into the heart through the pulmonary vein to the left side of the heart, go through the atrium, through the ventricle, back up and out into the aorta. Once it gets into the aorta, right, then it's going to take it to everywhere else in the human body. So it's just going to be branching and branching and branching off. Right? So there we have it. We've got our heart. We've got our deoxygenated blue right side. We've got our oxygenated pinkish red left side. And that's how your heart works. All right. If you guys have any questions, as always, let me know. I hope you're doing well.